Hello everyone, hopefully you're doing well and staying safe. We'll start up with our new lesson, chapter 12, lesson 4, electricity. So before we start up our lesson, we'll just have a small demonstration kind of experiment. You all have combs in your home, so have a piece of comb and some pieces of colored papers, piece of papers. You can rub off the comb with your hair and then bring the comb near to the piece of papers. What do you see? You've seen that the pieces of the paper, there's an attraction between the comb and the pieces of the paper. This is what actually the comb became negatively charged and the electrons moved from there. So this is what the phenomena of electricity is actually. So electricity basically is the measurement of electrons. Its energy is measured in joules, and we use the volts to measure how strong these electrons will move in electricity. So if you remember, we studied about atom. In atom we had protons and electrons. Remember, protons having positive charge and the electrons were having negative charge. So particles with opposite charges, they are attracted. For example, we hear opposite charges attract each other, while the like charges, they repel each other, they don't attract each other. So when two objects they rub against each other, electrons are sometimes they knocked off an object and onto another. They kind of jump from one to another. This may happen mostly when you touch a doorknob on a cold, dry day, and you see a sparkle of electricity happens. This is what actually this is called the static electricity. Static electricity is the buildup of these charged particles. So let's talk more about how this static electricity happens. The attractive forces between electrons and proton is strong. Static electricity causes these electrons to jump through the air towards nearby proton. That's why a spark is formed. Now these electrons have been discharged and returned to the protons. Now normally an atom or things are neutral when the number of protons and the number of electrons are same, but when it becomes positively or negatively charged, let us say here we have more number of protons, that's why it's positively charged, and here we have more number of electrons, that's why this is negatively charged. So two oppositely charged objects, they stick together, attracted. This is called the static cling. It often happens when, for example, you rub your clothes together in a tumble dryer. Charged objects can also attract neutral objects. This also can happen when a charged object nears a neutral object. It pulls one type of charge and pushes onto another. Then the neutral object will act like it's slightly charged on one side and attract the other charged object. So static electricity forms on a good electrical conductor, like a metal. Metal is a good electric conductor. The charges can move freely. Like charges will push on each other and spread themselves out. This is these same charges. If, for example, negative, they will push on each other and spread themselves out. When static electricity forms in an electrical insulator, charges cannot move freely. Insulator, remember, the anything which does not allow electricity or heat. If we're talking about electrical insulators, these are the objects which do not allow electricity to pass through them. Now, Earth is a large neutral conductor. It's a neutral conductor, so you can protect objects from static electricity, including even lightning, by grounding them to the earth with a wire. So grounding basically is when a conductor shares its excess charge with a much large conductor. Instead of building up static electricity, grounding objects pass the charge onto the earth so things can stay safe. The charge can spread out so that they are barely noticed and nothing happens. So this is what grounding is actually. So thank you for watching. This was our end of lesson. Please feel free to ask anything, and we'll continue the lesson in the next period.